Okay, so let's get into the configuration. There are some constraints when using TeamCity for a DevOps pipeline, and you want to use one versioned application for your Git repository. Some of the older version control systems, the centralized systems like Subversion and TeamCity, allowed an entire directory tree, and people put all kinds of applications and in different, what looked like subdirectories. But if you've migrated from that to a Git repository, and your Git repository looks like a massive network share with tons of applications, you're going to need to do some work on that in order to unleash the power of TeamCity when it comes to shepherding your DevOps pipeline. So I just want to hit up that point. This is a graphical depiction of what the structure of your build steps should look like. And of course, we need the PowerShell build script because you can see the similarity in the private build and the continuous integration build, which you can call it CI build, but the official term is integration build. You have private build and you have an integration build, because those are two stages of the overall continuous integration pattern. But a build is just a larger order of tests. So if you've ever done test-driven development, red, green, refactor, or arrange, act, assert, a build is a test. You do some things to set up, you do some things to arrange, then you do some things, the act part, you actually do the compilation and linking everything together. Then you have assert. Now we check some things to make sure that we're good. So arrange, act, assert. It's the same thing when it comes to a build. A build structurally is just like a test. And so we are going to clean past temporary files. We are going to stamp it with a version number. We are going to set up the database. You see the migrate database, because in order to do our asserts, we actually have to have a database online, because it is a dependency that the application has for storing and retrieving data. Whatever dependencies your application has in your architecture, you need to set up that dependency so that you can properly do a build that has any hope of running component level integration tests that bridge the code that pokes into those dependencies. And then of course in the act is compiling. I mean, with .NET it's pretty simple. .NET.exe build with some command lines, and then we run our unit tests, and then we run our integration tests. Then we do additional things in our integration build. We might add static code analysis. That's always a good idea. And we will publish the test results. We will package up each deployable piece of the application in a deployable package. And then we will publish those packages, which make up our release candidate. We'll publish it to our NuGet server. So that's the structure of a build. Now, when it comes to the process by which we finish continuous integration, this kind of finishes continuous integration with our pull request. So and this goes more sequentially. Developer is going to change some code, run the private build, then is going to do a git commit. The build server is going to spin up on the feature branch and create a release candidate off the feature branch. Now these are beta, alpha release candidates. Those are, if it's built from a feature branch, it's never going to go to production, but it needs to go to our first line test automation environment, because we need to know that what we just did still deploys and still starts up. And so we will deploy it. Then we will run however many full system automated acceptance tests we have. Then we know that whatever I did on my feature branch was good, and I can create a pull request. And then with my team's pull request inspection checklist, I can ask one of my team members, hey, would you check out my pull request? Yeah, that's how we tend to talk to team members in Texas. And then team member goes through the checklist. Of course, if there's any feedback, but all good. Click merge. And now we merge it onto the master branch. And then the build kicks in again, because now there's a change on the master branch. And then we deploy a release candidate, and then the full system acceptance test run again. And now we actually have a potential GA or generally available release candidate that can go further on to manual test environments and then on to production. So that's how this works.